Okay, get a shower, check. Let's get some shampoo, some soap, body wash, a phone stand, a timer, and a speaker. Now that's a lot of stuff. Let's try picking the shampoo up. Whoa. That's not good. We need a fix for this. This project is addressing 3 primary needs: organization in the shower, reduction of single-use plastics, and finally saving water and time. I'm aiming to create a series of modular products that can seamlessly integrate with each other, each providing a different function and addressing a different need. Through surveys and interviews, I asked people what factors they wanted in my product.
It needs to snap together and be waterproof. Should look nice.
Waterproof.
Minimal design.
Aesthetically pleasing, highly functional.
Magnetic alignment.
I've crafted a success criteria. Here are all the factors of success for my project, sorted from most to least important. As you can see, there's an emphasis on the functionality of each of the modules. Then, I have to make sure it is waterproof and can be attached to the wall easily. Finally, the minimal design and the magnetic alignment. For this project, I'll have to experiment with a large variety of materials such as PLA, ABS and TPU, equipment such as 3D printers and CNC machines, and most importantly, design ideas such as magnets for alignment and suction cups for wall mounting. First, I started with sketching ideas and getting inspired by personally crafted mood boards. Then I focused my direction towards one module, the automatic dispenser. I researched a wide range of design ideas, materials, and equipments that I could use. Then finally came the CAD stage on Fusion 360, which was then realized through CAM, through 3D printing. Then I evaluated the design and reiterated. The initial prototype was made to visualize my initial ideas and to get a grasp on the aesthetic look of the dispenser. I used PLA and my home 3D printer to realize the design. Unfortunately, the settings were not calibrated and resulted in poor print quality. But as I was focusing on the aesthetic aspect of this device, I believe it is quite a minimal and clean design, affirming the success criteria. For the second iteration of this device, I focused on the connection between the different parts of the dispenser. I used a simple plug-and-hole technique to align and grip these segments together. This didn't work that well, as I had not accounted for tolerances. The individual pegs also didn't have much grip, reducing the structural integrity and strength of the design, therefore failing the success criteria. I needed to experiment with connection. I created a small connection mechanism to experiment with how I could connect different segments. The mechanism was effective, but it didn't have a strong grip, which would reduce the structural integrity of the device. I went back to square one and started researching a wide range of automatic dispensers. I disassembled an automatic dispenser that I found at home to see how the mechanisms and connection work between them. For the third prototype, I decided to make a design that would rely on screws as seen in various other dispensers. By using a motor, motion sensor, and an adapter, I created a very basic functional prototype that sucks liquid and dispenses. In order to align the modules to each other, I experimented with a magnet mount and different types of magnets testing out their strength. The larger magnet that I had bought was pretty strong, but unfortunately it was a bit too large, which meant the smaller magnets, which also had a pretty strong connection, were best suited for this project. I bought a few different kinds of suction cups and tested them on different surfaces. Surprisingly, the smaller, cheaper suction cup had a stronger grip for a longer period of time as compared to the larger, more expensive one. More experimentation was definitely required. The final prototype was functional, dispensing around 10 mils. The portability needed improvement as I had not planned for batteries, instead I plugged it into the wall. The aesthetics were also compromised for higher functionality, and finally, the magnetic mounts were functional but hard to test well. Here's a risk assessment matrix for the equipment I'm using. When designing and producing this product, many safety practices were considered. I heavily used a 3D printer for this project, and to ensure safe operation, I implemented key safety measures. Proper ventilation and temperature control were maintained in the room where the 3D printer operated. A clean, even bed and closed door reduced risk of a failed print, minimizing the potential for fire hazards. I exclusively used PLA for 3D printing. Attention was paid to maintaining optimal ventilation within the room. When testing the strength of the magnets, I held the magnets far away from my eyes to prevent a potential injury as they randomly broke off, releasing small pieces. To clean up the 3D prints, I used tools such as pliers and screwdrivers safely. This was done wearing proper PPE such as gloves, while in a bright environment with a sturdy surface. I also used a power drill to create holes in the design, but I also used a clamp to secure the item that was being drilled into. The design is crafted with the intent to elevate the individual shower experience. Moreover, I have focused on the suction cups, enabling the utility set to be conveniently placed at any height. This improves the accessibility for individuals with disabilities or varying heights. The materials chosen prioritize user safety, avoiding toxic substances and meeting various safety standards. Additionally, a user-friendly manual with clear instructions will be included. Certain modules are designed to be shared within a community setting. For example, the timer module can be placed in shared shower spaces, growing a sense of community and resource sharing. The design places a strong emphasis on accessibility, incorporating features that cater to users with diverse abilities. Additionally, users have the flexibility to start with basic modules and gradually expand their set based on their specific needs and preferences. By prioritizing sustainability, product utilizes recycled and eco-friendly materials, including a biodegradable PLA, to minimize environmental impacts. Additionally, the design incorporates water-saving features such as timers for shorter showers and reduces plastic waste by encouraging the purchase of larger volumes of soap, shampoo, and body wash. The design encourages sustainability through easy module disassembly, allowing users to return obsolete modules for recycling, and the final prototype functions inconsistently, sometimes not dispensing liquid, but I believe I'm close to completing this criteria. I have not made much progress on the waterproof and wall mounting aspects, meaning they'll be my next goal. I've done a little bit of prototyping with the magnets and the design, but I'm not quite there yet. And that's all.